Hi, today we'll do live coding session to create an IMDb CLI. It will involve making an HTTP request to IMDb find URL, query result elements from fetched HTTP response, make HTTP request to IMDb for result titles details, query some key data points from response, say for director, and show the result on console. Now let's create a new Go project. We'll name it IMDb CLI for now. Init Go modules for it to be enabled during Go tasks. We'll start with a vanilla block and proceed to fetch valid HTTP 200 response for IMDb's find web page. Put in a placeholder results variable for now. When we search for a title on IMDb, it lets us filter for movies and TV episodes, video games. Differ based on get param and URL. Here it is T type with value TV for shows and FT for movies. Let's use this movie search URL for now. We'll keep it in a constant block for our code. Although currently we are in a spike mode, let's try to keep structure so when we refactor later it's not all a mess. So let's extract the title type and title search term get params. We'll construct required URL for title search in our function, which later can easily integrate with other title searches. Now we need to fetch it using Golang HTTP client. There are a few ways of doing it. We can simply use Golang's HTTP client library, which is decent enough for a spike, and even main projects depending on it parameter are utilized better. We can use packages like Heimdall, which provide a robust HTTP client interface, which like have retrievability and more. I'll just use one of my own OSS Golang packages, which I created a while back to get HTTP request quickly for a spike. Just a simple wrapper. I have a Golang package collection under github.com Abhishek KR GOL Goal. The sub package name is Goal HTTP client. It provides simple HTTP request struct to use standard Go HTTP client with some wrapping for ease. We'll pull in a simple usage example for it from the behavioral test we have and modify it to make some IMDb web requests that we need. Assign it our constructed URL. Make sure SSL skip is toggled on so the certificate issues don't bug us. We can keep it turned off and like if we need it for a particular case, but not here. Uh, and then make the GET request that we need. Now let's run this, and if we get proper response, we'll try query the first HTML. If not, we'll try fix it. Assign response to a result placeholder and run it to check result. We are getting 404 HTTP error. I will split our console and run code side by side to see a quick impact. My guess is we shall pass some useful HTTP request header like user agent etc. to our HTTP request, which might be the cause for this failure. We have HTTP header field here. That's good. With a string eval map that we can assign it to. While we are doing it, let's also add getParam string eval map for all getparams that we need to pass, which are currently part of the URL string that we have. T type for title type and Q for title query string. Let's extract the HTTP client for IMDb to a function for now. We'll return IMDb's HTTP request construct for it. I'm a bit torn on this name, and if it shall return response, let's come back to it. I forgot to use correct URL base now, as we don't need to construct with get parents. Let's use our IMDb client function and run it. I'll crypt run output with pylib to see if any useful response is there. Not just because proper HTTP 200 response is received doesn't mean all need HTML is present, so we'll just scroll a bit and see if it makes sense. Let's proceed with querying now. Yeah, we have good. So there are a couple of good libraries for HTML parsing in Go. I like Go query since it kind of mimics the contract of jQuery and code looks a lot familiar. Uh, for now, I'm looking for an old usage of GoQuery in one of my other goals packages called Goal GoQuery. I'm not directly using it for now. This is a package because I want to use the DSL version of this wrapper package, which I want to introduce while refactoring later. For now, we'll just see the simple use of GoQuery and see how easy it is to use. We'll use the new document. But it expects a URL, so we want to control the HTTP request portion, so we'll change it to something that can use the response directly. We have pulled a new document from Reader, which presents us with doc that we can find on using selectors. Let's inspect find page in Chrome to identify selector query. Let's fetch the example of find where it iterates over all elements onto a selection. Get text fetch inner HTML content between selected node. Let's print them. Still failing as we are passing string instead of IOReader. Let's fix that. Piping response through strings new reader does that. Let's pre-print the titles and see if we are good to go ahead. Let's make the selection query more specific. It's better to avoid frequent breaks, small web page updates. So we'll just be more fine-tuned with it. Now that we have it working, let's get titles link as well. So we can fetch the title page and pass info from that as well. There was a selection method like attr, the attribute, to fetch value from node attributes. Let's check if this much works. Okay, now to request title page, for now let's create a function similar to that of IMDB, a find web request. We need to do some refactoring to avoid it a mess. Let's have an IMDB request as baseline HTTP request creator. We'll assign get params for movie find in IMDB find request. Let's call it find movie, or rather. Let's have arrays of movie identifier in response returned from find movie. We'll declare a simple struct for now with just name and link for movie. Let's pull out IMDb title selection query to constant. It's a constant config for a runtime. Let's check if selection here provides length of items. We'll create movie array of same length, populate them and run it. attr here returns value and exists. So let's use something that returns value or default value if missing. Let's see if this still works fine before we move ahead. Now let's fetch director for these titles. We loop over return found movie titles and get movie details per entry. Actually, we don't need a separate movie detail entry. The details belong in movie struct and shall be accessible as such. So we'll have get details of a movie. That's it. Now let's pull the HTTP request portion required to make title page web request, where we can fetch movie details from. We'll need a URL. Let's see this URL structure. The link portion we already have in movie details can be used to construct the URL we need. Similar to titles, let's inspect selector for director name. I see multiple credit summary item nodes as array with only one having director entry. We'll have to filter that. Let's first fetch all the items with this filter of credit summary item. We loop through all and try to find node with desired heading h4 with director value. QueryQuery lets you fetch parent of selection. Let's pull out heading level selector string out to constants. We can iterate over those and fetch parent for director matching selection. Then pull name and link for director from it. Let's see if parents filtered can give a selection within parent for the link. I have not used it before. If this doesn't work out right, we'll switch to simple parent query. We'll pull all link nodes for credit summary nodes. Fetch its first node and move cursor ahead each iteration. Now this will help us later when we are refactoring, say, other movie details from credit summary. Let's fix index error for this range. Some movies are getting director details, but some like Midnight Club are not. We need to fix that. Let's visit the title page and try and analyze why GoQuery didn't work for that Midnight Club title HTML node. There are more than one director on this title, which is like different from the other sample case that we had. We need to update our node match query for one and many directors. Now we'll introduce a struct for director. and a movie will need to have an array type with. Let's call this new struct artist. For now, it will only have name and link. We'll fix type and check it on output again. Now that we are getting first director correctly, we'll update it to fetch list of available. Here credit will have list of director detail nodes. We'll iterate over it to get the required director details. Oh, I forgot to update couple director instance. Should have done the Vim's find replace before anyway. Let's fix it for pretty print. Oh, there's a bug in director assignment. Oh, this should be credit, not S selection. Let's see if we get correct output in this run. Nah, we still just get one director. Let's place logs for individual credit and just run it for a failure case. Oh, since it's just for one linked list, index shall be simply 0 for failed use case. Um, we see just one element long selection list for parent logic. Let's analyze and fix that. We see that credit summary nodes have one H4 and linked child nodes each. Let's just make credit summary assignment simpler. That's backward. Now length is for all artists, not just director. It's wrong. Let's reword it first. There it is. Let's just pull in parent query for a specific node of director so parallel index doesn't fail. Like that has been a mess for now. We don't need credit variable here altogether. We can get rid of that. This still fails, means something is still wrong. Let's just look. Oh, oh, we need to use S as specific selector, not full selection set. So this worked now. Let's go ahead and remove the temporary test pieces. Let's test this again. Cool, it works. Now we have a title where we still don't see a director entry. We need to check what's up with the director detail here. It's empty here because it doesn't have any director. So, okay, that's good. So here we go. Now our program works to fetch movie's director. Similarly can be used for cast and crew later on. Works for multiple directors. Doesn't fail for no director. And next time in this we'll fetch other details, make it a bit better, refactor it. Till then, try out